Good afternoon, everyone. Welcome to Mighty Line Minute. I've got a wonderful show today. I've got Richard Puig with Newson-Gale from the UK, who is the product manager here in the Americas. Richard, I'm glad to have you here. I appreciate you taking the time. And we're going to talk about a great subject called static electricity, more importantly, static control. I think you and I both feel that this is an important subject people need to learn more about. So thank you for joining us today.
Thank you very, very much for the opportunity. And I always like to talk about the subject of static electricity and trying to help customers protect their personnel and facilities. So very excited. Thank you very much.
Well, thanks for joining us. And I have to ask, how did you ever get into this field? Newson-Gale, I know, but I know a lot of people out there don't. But how did you get attracted to this field of static control?
I was already in the fire protection industry and knew a lot of the background of explosion and fire protection. And hazardous area static control, which is what we do, is a niche of the fire world. And it is more prevention versus in fire and explosions, you're trying to respond. Here, we're trying to prevent by putting measures in place and practicing good practices in regards to hazardous area static control.
So many people don't seem to know the realities of controlling static electricity, and I find it always an interesting subject. I'm not basically a technical person, and I've had to learn this field. And when people come up to me and say, am I wearing the right footwear? You know, is this a hazardous location that I need to be concerned about bonding and grounding? And what about bonding and grounding? What about my footwear? The questions are endless. How do you begin to get education in this area?
It is tremendous. And first you just start with static electricity and how is it generated. And first, let me say, we attend to customers in multiple industries, from pharmaceutical, paints and solvents, inks, petrochemical customers, food, anybody who moves flammable and combustible liquids or dust. And that can be from what we know, gasoline and methanol and ethanol, to sugar and flour. The whole extreme. So first, static electricity, we have to understand that it can be generated in any process where material is moving, mixing, flowing, materials are sliding against each other, and static electricity can be generated. Now, in very simple terms, materials flow against each other, and some materials are going to be more susceptible to give up or take electrons. And so they end up out of balance. In a molecular level, you're looking at the atom and saying, I don't have enough electrons, or I gave up a whole bunch and I have too many now. And so when molecules are out of balance, in nature, we know everything tries to return to a balanced state. And so when a molecule is way out of balance, it's going to try to find balance, unfortunately, in the form of a static discharge. Give away all those electrons that are causing me to be out of balance or heavy, and that is what we don't want. We don't want materials that are out of balance and therefore seek a balance by discharge. Now, let me go ahead and say some materials are more susceptible to generation of static electricity depending on their molecular qualities.
So we're talking about conductivity and resistivity?
Exactly. We're talking about conductivity and resistivity. You find water, superconductive, easy, balances itself, but something like methanol or toluene is not as conductive. And when it finds itself out of balance, it can stay out of balance and reach a larger out of balance state. Yes. Not good, because then when it does find an opportunity to balance, that's going to be a big spark.
And those problems can even happen within piping, internal to piping, and the length and the velocities and the flow rates. So it can get very technical.
It can get complicated. One of the things you sort of touched on it is when you have material that's flowing, the faster it flows, the more touch there is, the more passing. And so flow rates can greatly affect the generation of static electricity. Yes. And you can have a material that's flowing through a pipe and it is balancing itself against the pipe by hitting it with sparks. And you can have pinholes in small pipes, especially pipes that are lined and they discharge. So you can see the effects sometimes of what static electricity can do to damage equipment.
I've had the opportunity to visit your Nottingham facility where you do manufacturing, and I was very impressed with your quality control, the people you've got working for the organization, all of them are top notch. And we don't have enough time here today to get into all the detail about static, but a question I often get has to do with the employee themselves and how to control the risk that they may present in a hazardous environment. I've seen flooring where someone installed epoxy floors that are not static dissipating or static dissipative and present a hazard to the employee. On the other hand, if you've got a concrete floor, you've got the issue of people wearing static dissipative footwear, and whether it is or isn't, are there systems available to assure that the employee is releasing static from themselves in an operation?
Yes, but first let's just real briefly, we talked about materials that flow and go, and that's when static electricity is being generated. The same thing with the human person. That person is moving. He's flowing across the floor. He's picking his feet up, shuffling, and depending on what the floor is, that person can generate static electricity and hold on to that static electricity if they are not grounded, i.e. if they are isolated. So if you have non-conductive footwear and you're walking across the floor, you generate static electricity, you walk up to a doorknob and you discharge, you've just got equality against the doorknob and you discharge. And that is what you don't want. You don't want individuals that are isolated and will generate static electricity and hold it.
Well, particularly if they're removing stretch wrap from a pallet load in a hazardous area. I mean, first, that shouldn't even enter the hazardous area in the first place.
Right.
But you can see how someone could gain that charge, even if it's not their footwear, just by handling a material that shouldn't be in the hazardous zone.
Right. Our most common with footwear and people is individuals, employees working in hazardous areas, walking up to a drum with flammable material or going into a process where there's flammable material. We don't want that individual to be charged.
Yeah.
So the plant managers, the HS managers want to make sure that they have static dissipative footwear.
Yes.
And you really need to think of two things. One is static dissipative footwear and a conductive floor.
Yes.
Because you can have static dissipative footwear, but if your floor is isolating, then the static has nowhere to go.
Yeah, so you have to be familiar with what the floor is coated with or not. So bottom line, bare concrete is better than coated concrete, unless you know what you're coating it with.
Exactly. Good. So back to footwear. So you want to make sure that footwear is good and appropriate. And we do have a tester because shoes get old, shoes, you lose their conductivity. Maybe you work in a facility where you got it covered with paint or product or something. You want to make sure every day that you walk into that facility that your footwear is correct.
Yes.
So we have a footwear tester called the Soulmate. You stand on it, push the button, runs a intrinsically safe circuit through you to the plate and verifies that you have a certain level of conductivity.
Now, a visual indication with that as well.
It is a visual green light. Now, one of the things people don't realize is that system actually tests the individual standing in the footwear.
Yes.
You could have bought footwear this morning, be perfect, and you put on nylon or rayon socks, which are not natural fibers,
right?
Or you put an insole into your footwear, you just voided the conditions of your footwear. So when you hit the tester, you touch the button, the circuit runs through you, through your body, through the footwear to the plate, and verifies that you, the individual, and the shoes are dissipative all the way down to the floor.
And it's a safe level, by the way, so
absolutely a safe level, got to be there. We've seen some customers do this very well. One of the best examples I saw was a company, I can't name the company, but they put the footwear tester right outside of the hazardous area and interlocked it to the door.
Wonderful.
So the employee came, stood on the footpad, tested himself. The system unlocked the door when he passed, and he could go in to the hazardous area. That, I thought, was the best example.
I love hearing that. You won't see that, folks, in many places, but that's a state of the art.
That was a good. So we sell the footwear tester, but really we try to help the customer bond and ground in his processes. Yes. If he's loading a truck or unloading a train, a truck, a tote, a drum, if he has a mixer, all these things where the human being is involved and there's movement of material that could cause static electricity, you want to make sure that you have a connection to earth and you want to make sure that they've made a good metal-to-metal contact with the drum, the tote, the rail car.
Yes.
And they have a valid connection all the way back to a verified ground point.
Correct.
A ground rod or a ground grid.
And your systems will confirm that visually as well, right? Got that capability.
Absolutely. So we have systems at the highest level that verify, hey, I have a connection back to Earth with a resistance of less than 10 ohms. As per many of the standards, 10 ohms is the quality mark telling me, hey, I can dissipate static electricity through this wire, no problem. Back to Earth, we get that confirmation. We provide the operator red light, green light. He knows he's in a good or a bad condition. We have interlocks to interlock into a pump, a valve, a mixer, however the customer wants to exercise process control.
Yes.
And we don't tell them how to exercise. We just give them the dry contacts so they can do it. Customers can be very, very inventive. I find it fun to see how people exercise process control, but I'm happy to see them do that.
Yeah.
If they're not grounded, if they're not bonded, if they don't have a green light, their systems won't work, so they have to stop, investigate, and correct the situation, bond and ground themselves so they can move forward.
Richard, you've been wonderful on this subject, and I have to tell you, we've gone from safety 101 on electrostatics to safety 201 this morning, and I appreciate your time on that. I do want folks to take a look at Newson-Gale. Where can they learn more about your company, your equipment, and the services that you provide?
First, I would tell people, direct them to our website, Newson-Gale, Gale.com. And we have a very good website with all the information. Put in a request there. We're happy to have a regional manager meet you in the field. We go out directly and meet customers in the field. We have 6 regional managers in the Americas and a product manager here to help you. So I would tell you to first go to the website.
Great. Well, you've got a great display. We're glad to see you at the Professional Development Conference here in Denver. And good to see you again, Richard.
Oh, thank you very much.
Thanks for sharing your stories with us. Folks, take a look at Newson-Gale and make sure you take advantage of their services. Have a great day. Be safe. We'll see you again on Mighty Line. Take care.